Hello and welcome to Everyday Challenges and Opportunities with LLMs. I'm Sree Kamireddy, VP of Product at Fiddler AI. Today we have the privilege of hosting a panel of experts, each with a unique perspective on the dynamic landscape of generative AI. Our esteemed panelists include Sara, Director of Cohere for AI, Jerry Liu, co-founder, CEO at Llama Index, Jeff Huber, co-founder at Chroma. Let's dive into the discussion. Maybe we start with a hot take. A hot take is that we are only scratching the surface of enterprise generative AI's potential, with many applications yet to move beyond prototyping. What challenges are keeping these prototypes from reaching the market and delivering real business value? Sara, what are your thoughts on this?
Hey everyone, it's lovely to be here. And especially with the perspectives on this panel. So I lead research at Cohere for AI. I would say it's first interesting to note like why we're all here. Why is a whole panel called Challenges, Opportunities with Generative AI? Because it's been such a surreal year. As someone like who works on these type of models, it's just really odd and a roller coaster to have so much excitement in such a compressed amount of time. A lot of what my research team works on is, I would say, two things that I think are really critical as you think about how to bring what people are excited about with these large language models, the fluidity, the dynamic nature of the interactions, which really are breakthrough in language technology. It's one, efficiency. So a lot of the work in my lab is how do we make these models more manageable at scale? That includes things like novel quantization techniques, but also things like, do we need all the data we need to pre-train? How do we accelerate training? And this is because a lot of the breakthrough in these models has been caused by this trend of bigger is better. And so a lot of what's interesting there is how do you condition that and how do you get away with less? It also involves things like adaptation, which is the second thing. I think the second big question which we work on is personalization. So we've moved, this is kind of a critical thing. One of the biggest differences in how we model is that we've moved from many small models that each do one thing, like toxicity or sentiment detection, to a universal model paradigm. But what that means is now techniques which allow for personalization. So you use a general purpose model, but then you tailor it, becoming much more critical. So a lot of my team works on that. I think techniques like RAG, but adapter style fine tuning as well, things that do it more efficiently are very critical in this space. But yeah, maybe I can open up so Jeff and Jerry can also join in.
Yeah, that's quite interesting. I think you're absolutely spot on, right? Like efficiencies are quite important. Yeah, Jerry, love to hear your thoughts.
Yeah, I think what Sarah gave was a great answer. I think just to add on to that, I think you're seeing a lot of developers enter the space, and a lot of them don't have a ton of ML experience. And so I think one of the beautiful things about LLMs is the fact that basically any engineering team can just deploy some capabilities of generative AI without having to invest in data collection, training, engineering, and really the know-how like data science and kind of evaluation, or at least not yet. To realize some like the 80-20 rule, right? Like some initial value from that they built. But I think that's precisely the issue is that it's like the time to value to do something is a lot shorter. But then once you actually build something like a RAG pipeline, right, or some basic agent workflow, you start realizing that there are certain failures like hallucinations, like retrieval problems, and the more parameters you tack onto the software system, the more stuff you have to tune. And I think most developers actually don't aren't like fully aware of that when they first start building these things because they don't a lot of them don't come from like a traditional ML background. And so as a result, I think it's interesting to see how the overall practices around this like AI engineering space evolve over time, as well as like how much just like general evaluation principles that everybody has to internalize versus like the core research problems that like mostly the ML engineers have to, or the deep learning researchers have to basically solve.
Yeah, that makes sense. So, well, I do want to hear Jeff's take on this, but before we go there, yeah, you mentioned about we don't, the teams don't necessarily need as many skills as say building a predictive model. But what do you feel are the core skills that the teams still need to have so that they can be successful in this generative AI journey?
I think at the current moment in time, like from talking to enterprises, pretty much everybody cares about evaluation and benchmarking. And I think that is one of the issues. And so basically every team cares about this when they're building LLMs, because once you build an app with LLMs, you realize it fails, then you realize you need a way to measure and then improve things. And I think that is something that probably everybody building apps at least needs to know right now. There is a future where, all these models get better and none of this really matters. But like, I think as we're, as like people are progressing towards that future, I think people still need the ability to more principally, or in a more principled manner, kind of like track and optimize it, like improvements to their app.
Yeah, absolutely. Evaluations and benchmarks, so important. Jeff, both questions, I think I would love to hear your thoughts on both the questions. What challenges are preventing prototypes to production, and what are the core skills?
Yeah, I mean, I think to zoom out a little bit, one of the ways that we think about this is really what large models represent is a new way of writing software. It allows us to create programs and software that we could not have created before with just using code as a tool. But of course, code has all these advantages where code is, fairly deterministic as long as you're not having, bits flipped by radiation in space. It's like your code will always run the same way. Obviously, that is not true about using these new primitives in the loop. You don't get these sort of stochastic by definition, it's statistical by definition. This is part of the advantage. These sorts of systems can handle a lot more complexity. They can take very dynamic inputs, right? Versus conventional code is very strict about its inputs. There's also a challenge to building, reliable outputs. And so I think that like broad frame is pretty important. Obviously, if this is a new way of building software, it's going to take time for like best practices to emerge. And so in some sense, I don't know, I don't necessarily think that it's super important to be like rushing to production as fast as possible. Like it took, software best practices, 10, 20, 30 years to really emerge. And even still, they're still emerging. And I think the same will be true for this arc as well. So in terms of skills, I think that like the thing that like I would encourage every sort of practitioner or aspiring practitioner to do is like just play with the tools and understand them. Obviously, if that's in sort of corporate sanctioned way, that's great. If it's in like your spare time, that's maybe even better. But just read about and go play with these things on your own. You're on your own laptops. It's really easy to run language models locally now. It's pretty easy to even like fine tune them on small amounts of data. And I just think that having that muscle memory and understanding like the shape of tools, that is the most important thing for practitioners to do today. I think that, trying in some sense, like trying to contort these things, like make them do production. Again, maybe it's a good idea if that makes sense to your organization. But I think that like from a longer term perspective, if you think about people's like career arc and career development, yeah, it's just like learning as much as you can and playing around with the stuff.
Yeah, that's awesome. So benchmarking, evaluations, learning, maybe even go all the way to fine tuning and really you get a hang of it. Sara, any thoughts on the core skills that you think a team should have to make them successful in this journey?
Yeah, I really like Jerry's perspective on this. I think what I would say about benchmarking is that often end users become overwhelmed by this notion of benchmarking because we're in this weird kind of collision where we have tons of academic benchmarks that were designed for kind of a different era where it's to evaluate one model. And now they're all packaged as kind of collections of benchmarks. But often these academic tasks are very different from the tasks that you probably care about in your day-to-day. So I actually would just further and say, to Jerry's point about what skills you need to gain, is as domain experts, you probably know the 3 critical tasks in your business that you want a model to perform well at. And so the skill is creating golden evaluation sets that work for you and your use cases, not necessarily having to master all the different benchmarks that are out there, because that's probably less relevant. In fact, we often see tension between performance on academic benchmarks and performance in what often we think of as like the fluidity of these language models or their ability to kind of deliver on dynamic discourse. It actually is in tension because academic benchmarks have favored these one-word answers and like complete precision on that. And so we're in a different era. And so what matters most is you take the time to actually collect your gold standard data and make sure that's never used for fine-tuning, but is used for you to do cross comparisons across time.
Yeah, that's a great take. That thank you so much, all of you. Like I think the golden evaluation data sets, I think that is clearly a unique skill. And like Jeff mentioned, this is a completely new way of writing code. And I think the insightful aspect that Jeff mentioned was, hey, why do we even need to rush? Like, let's take our time and do this right. I think it's a really great insights. So one aspect that I was wondering about was retrieval-augmented generation has gained a lot of traction recently. Over the last few months, I've been seeing recent updates from AI platforms that have streamlined the approach through, say, automatic chunking, storing embeddings, retrieval, maybe sometimes along with citations. It would be great to hear your perspective on the potential effects on the broader LLM ecosystem and the uptake of generative AI within these enterprises because of some of this streamline and simplification. Jeff, any thoughts on this?
Yeah, I mean, I think it's really cool actually, referencing like OpenAI Demo Day on Monday or Dev Day on Monday, right? Like you really saw for the first time, like a formal sanctioning of RAG from OpenAI. Like previously, they're sort of non-committal to it. I remember talking to friends at OpenAI earlier this year about retrieval, and these friends are sort of like, yeah, I don't get it. Probably won't matter. And now you're seeing like OpenAI sort of say like, no, this is actually, we're going to educate developers on the technology and how to use it. So that's actually a big moment, I think, for retrieval and for approaches with retrieval. I mean, obviously, we at Chroma, maybe we're biased, but we really believe in retrieval. We think that like retrieval really is a really important key, and we are in the very first, really the dumbest way of doing retrieval today. There's a bunch of really exciting stuff happening in academia and coming down the pipe, which we think will lead to much greater interpretability and reliability of models. But without going too deep down that path, again, I think that like it's pretty cool to see, OpenAI being this is like saying this is great. And obviously Cohere was before them, right? I think it was like a couple months ago that Cohere launched a managed service around RAG as well. So yeah, I think that's great. Obviously at Chroma, like that's sort of RAG as a service, right? Which is like a very much its own thing. We at Chroma want to serve open source developers and help them build and host their own data and, serve a multiplicity of embedding providers and language model providers and integrations and plugins and all the things, right? And so, I think there's a natural verticalization effort you see amongst like the large language providers, mostly in consumer applications to consolidate the user experience that, naturally you could do, right? If you go very vertical, you can make a greater user experience for like a consumer or an end application. But then you also have folks, obviously, like Jerry, Llama Index, this project, Chroma, and others, right? Like building these like horizontal layers. And so I think that it's all good, right? This is like a rising tide, and we're all, again, very early in all this stuff. So
Yeah, rising tide it is. Absolutely. Jerry, any thoughts on this?
Yeah. I mean, this idea of RAG, I guess we're calling it RAG now. It used to be called like in-context learning or something last year-ish. And then before that, I don't know what it was called. It was basically the foundation for how GPT Index started, like around this time last year, actually in November. I was thinking to myself, like, like how do you build an application with GPT-3 and you just like stuff into the context window and then kind of like hack around it so that it actually understands the information, right? So you figure out how to like stuff as much information or relevant information as possible into the context window so it can reason over new data. That kind of led to basically the project like GPT Index and now Llama Index. And now, yeah, I mean, I think we've been thinking about RAG problems since around last year. And I imagine like, I talked to Anton from Chroma back in like January or February for the first time. It seems like we're all thinking about like similar things back then. I think it's super interesting. Like I think it's basically the what I think is like a kind of new type of ETL stack for LLM systems. Like traditional ETL and data pipelines is really about like how do you take some data, transform it, right, and then like put it into, for instance, like a Snowflake warehouse so that you can like get operational insights from it. Here, it's basically how do you take all this mess of like unstructured data, structured data that you have lying around in your data silos within the enterprise, or if you're just like a person, like you have your notes and stuff and your PDFs and your PowerPoints, like how do you take all that and just like put it into some format so that basically whatever question you want to ask over your data, no matter how complex, you can basically answer that. To me, that's like kind of one of the promises of RAG and kind of what we've been trying to push for. I think right now, as Jeff said, RAG is very basic. I think a lot of people building RAG systems, or at least like the like easiest way to build RAG systems is very basic. You just do like top K lookup. But there's a lot of potential innovations, both on the retrieval side, and OpenAI, just launched the retrieval API. But that actually is relatively like, it's not like they invented some fundamentally new thing. It's just like, like a decently well run like retrieval API. There's a lot of innovations there. And then there's also just like potential innovations on how do you actually combine LLMs with retrieval. And so I think there's been some interesting discussions on that lately that might disrupt the whole like pipeline and architecture of how these things are built. But basically, like it's just like a novel way of like taking your data, transforming it, and getting insights from it. And I think that is something that like this whole LLM like hype wave has inspired that wasn't really possible before this.
Yeah, that makes sense, and hopefully that improves the reliability and the factual nature of the answers. One thing, Jerry, I wanted to continue on was you mentioned here a lot of teams are just using say top K for retrieval and aspects like that. So I'm curious if you have a couple of top tips that you think are low hanging fruits that the teams have not used in at least for this architecture.
Yeah, I think maybe just two. We have like entire presentations on this, and so I'm happy to pass along those resources. But maybe just like two to start with. One is I've seen other people also tackle this idea of like decoupling the chunk used for retrieval versus the chunk used for the LLM. And so instead of embedding like a giant text chunk, maybe embed like a smaller reference or a summary of the underlying data you're trying to reference. And then embed that, and then when you actually feed the context to a language model, you retrieve the larger text chunk or whatever is referenced. That tends to be pretty powerful for enhancing both retrieval and synthesis. The other idea is just adding metadata, adding structured information to like vector databases like Chroma support like metadata filtering. And I would encourage people to take advantage of that because like just storing just flat chunks of text is probably like the most naive thing you can do.
Yeah, that makes a lot of sense. I think you're basically saying embed the meaning, not the entire document. And with that embedding, when you retrieve, you can retrieve the full document and use the metadata in a structured manner. So it's not always just unstructured, but both structured and unstructured, and take the power of that. That's pretty interesting. Sara, we're interested to hear your thoughts on the original question, which is about all of the AI platforms. Some of the AI platforms in the recent months having streamlined this RAG architecture. How is it going to say impact the space in general, but also the uptake of generative AI in the enterprises, and maybe a couple of top tips you have for the teams to implement Gen AI easily.
Yeah, and I love it already. The discussions from Jeff and Jerry were all like, "Oh, it's a bit cheeky that this is being discussed now because we've all been working on it for a while." So, yeah, Cohere's invested a lot in the space. So, I think we released our RAG kind of productionized version earlier this year. I think it's worthwhile thinking, why is this meaningful? Like, so the key challenges with large language models are personalization, but also falling out of date. So these are large models. So it's very expensive to retrain, to fine tune. In fact, like a lot of the work is like, how do you fine tune easier? So RAG is really this idea that you can couple a large language model with an external database, and you can kind of overcome these issues with your data being very different from the large language model, or your data changing over time, which is like most of the world. Like when you actually move outside this like weird static kind of research use case, most of how people actually use models involves new data over time. So that's why I think we're all so excited about RAG. I think that what's interesting in terms of what enterprise people should think about is integration. So your data probably as a company is in many different settings. And I think a large question would be, how do you make integration really easy? And how do you make it easy to work with existing databases? So this is like a really interesting both technical challenge, but also for enterprise. Think about this as you think about how you want to, what provider you want to go with, and what technical support that you have. The second is, I completely agree with, and I think this is what Jeff was alluding to, this idea of like, how do you work with all these different setups? To Joe's point, I also think it's really important to think about what you put in your database. So we've done a lot of research. We've actually released papers on like RAG for toxicity mitigation, and in general, showing how you can mitigate a lot of this drift over time by using these retrieval combined with, I agree, the notion of how you retrieve and the lookup is also important, but perhaps most important is what you put in and the way that you structure your data that you put in. And this is really interesting, and it's worth thinking about and talking to someone who has experience with RAG, because it makes a big difference in the overall performance. So these are just some things to think about, but I think the reason we're also unanimous in the fact that, oh, it's nice that this is getting the attention that it deserves is because it is a really meaningful way to pair large parametric models, which are very costly to retrain, with something which is more flexible and can be personalized for your use case.
Makes sense. Makes sense. Let me jump to a audience question that just came up. As one of the panelists, I think it's Jeff that mentioned reliability is a key thing. How to achieve it? How to create fallback plan? Can LLM just answer that? Hey, I don't know the answer, or some confidence score and integration, so that there is a fallback strategy. Pretty much the question is saying, hey, if LLM, if you don't know, please say so, right?
Yeah. I think that, and I'd love to know Sara and Jerry's opinion here too, but we have ideas here that not yet fully manifested yet. We've been busy with other things, but we think this is possible. And so, intuitively, right, if you have a supporting sort of database of evidence, so it's, fundamentally pins on a map, right? That's the analogy for latent space. It's just pins on a map. It's a high dimensional map, but it's a map. And then you land a query pin and there's no supporting evidence anywhere nearby on that map. Maybe you don't know about that. Maybe you shouldn't sort of move forward confidently, right? And so there's something about that like density of embedding space, which we think may be one powerful tool here. Related to that is an idea around like fencing. And again, these are ideas that I haven't even seen like reach production yet. So we're kind of maybe reaching a few months forward here, but using embedding spaces for fencing as well. And so saying like, okay, these inputs or this domain, this section of the map, both for inputs and outputs, I'm going to green light. And then, if the input or output falls out of distribution, falls out of that green lit area, it's going to raise an escalation somehow or throw an error or something else like that. And so I think there's tools there that, I think to Sara's point, historically, a lot of this stuff has not been done in academia simply because the incentive structure wasn't set up for shifting data sets, right? You want static data sets. That's how benchmarks work. But real world data is not like that. And so I think that sort of explains why there's like a lack of these tools today. That being said, obviously there's a lot of interest and effort in this direction. And it's something that, obviously at Chroma, we're interested in pursuing more on the research side. But there's plenty of, it's open source, right? So like, plenty of people all over the place that I think are doing interesting work here. So that's like one thought and some ideas.
Awesome. So essentially, if the answer is not in the space of what you've been trained on, hey, how can you be confident, right? Like that's one approach that you mentioned. I'm curious, Sara, have you seen in your research anything around tagging the LLM response with confidence?
Yeah, I think so. I guess it's a few different levels, right? There's one where typically productionized models have a layer which is fairly simplistic, which is rule-based, where you don't want to do response. But then there's also conditioning of the model space where you kind of train to not respond to certain types of questions. Jeff, I think what you're talking about with fencing might actually be similar to what we saw with the stable diffusion safety filter, which was a little crude because it was open source, so it was easily perhaps subverted. But the idea there was embedding similarity with some embeddings that were non-disclosed that I believe was inferred or was very related to violence or nudity. And so if the embeddings were too close, typically the stable diffusion would fail to produce. So these are existing ideas. I think we need to add, much more research momentum around them. But there are ideas which are currently productionized around this idea of where you abstain, what's the core problem here? The core problem here is that typically, if you clamp down on low certainty generations, you also get rid of what people really like about these models, which is their creativity. So we often talk about hallucinations in a bad framing when it's decoupled from factuality, but it's also what we tend to like about like, oh, the ability to interpolate. And that is most creative, but it tends to be in a sparsely populated space. So there tends to be this tension. So what I would say is a real interesting research question here is how do you distinguish between those sources of uncertainty? The real goal is you will have many sparsely populated spaces. Some are actually quite quite useful for how people think about these models as engaging or creative or iterative. And so we want to decouple those from these that are really what annoys us when they get a fact wrong, or when I type in, tell me about Sarah Hooker, the ice skater, and it gives me this amazing kind of story about me winning a championship, which is not true. So I think that's the interesting research question that we actually have to tackle.
Yeah, maybe soon, Sarah. Maybe soon you'll win a championship.
Oh, perhaps. Well,
Just,
according to widely used LLMs, it's already happened. I won the championship twice, so I'm now retired.
oh, breaking news! LLMs can predict the future. That's what's happening right here. So one thing, a couple of questions I wanted to ask based on what we have discussed so far. One is, let's say I've created this golden data set for evaluation and benchmarking that we all talked about, right? What are those metrics that now I as an enterprise should track so that I can deploy LLMs with confidence and responsibly? Right, Jerry, you have any thoughts on that?
Yeah, sure. I mean, I don't think, to be honest, I think everyone's kind of still figuring this out in terms of like a standard set of metrics that works for like every use case. And so the cop-out answer is basically like some of this is going to be kind of use case specific. And so actually every enterprise team building Gen AI should probably figure out like the right business metrics that they want to optimize for. For instance, like if you're a consumer app, like a lot of people, it might be okay just to test in production, just run A/B testing on whether consumers actually like the responses, right? And collect user feedback. For stuff that you can't really test in production or get consumer feedback, you might want to have good offline metrics, but some of it might be very use case specific. I can just talk about like some basic metrics that I think we have within the core framework that I think like there's evaluation libraries these days that people are using as well. Some basic ones is basically using LLMs to evaluate other LLMs and figuring out creative ways to do that. And so if you have a ground truth golden data set of like question and answer pairs for RAG, for instance, you can basically just use an LLM to compare the predicted response against the generated response. You could also compare that via like the right embedding representations, but that's kind of like an open problem. We haven't been able to track like how good like semantic similarity matches up to like the kind of relevance of the answer. Another one is if you're building RAG, for instance, you should probably just do benchmark retrieval on its own, which is not an LLM problem. It's just a retrieval problem. If you don't get back the right answers, you're not going to get back the context that LLM could use to actually synthesize something. And so that's just a ranking problem. Like you use like NDCG, MRR, you can basically create some sort of ground truth golden data set of retrieval and then see if that works. And then maybe the last point I'll make is I think that is one part of it. And then the flip side is the fact that there's some interesting things with like interactions between retrieval and synthesis that happens in RAG that is an argument for more end-to-end evals, because a lot of times, like if you do like re-ranking or if you do like different like chunk sizes or something, like there's things that might improve your retrieval metrics that don't necessarily improve your generation metrics. And so you probably want to have both.
Yeah, that makes sense. Awesome. So Jeff, any thoughts on this? Anything to add? Any areas we should deep dive on for this?
I would second everything Jerry said. I think it's right on point. I would actually double down and say you should go even deeper on like benchmarking your retrieval system. So one thing that people don't necessarily realize about how most retrieval systems work is the moment you flip from known nearest neighbor, which is a brute force approach, to approximate nearest neighbor, which is fast, it is approximate. And how good your approximation is strongly dependent on the type of embeddings you have, how often you're updating those embeddings, and then the underlying algorithm that powers that. And we've seen in some cases, like not to get into the name of names, but like, there's certain scenarios where people's recall, which is, if I brute force it, I would get back these 10, right? Okay. If I do a approximate nearest neighbor, I expect to get back 8 or 9 of those at least, right? And you've seen cases where people only get back like 5 from those 10. And so obviously, as Jerry was saying, if you don't get back the right retrieval, like good luck with the generation. And so this is one thing that I think people are not sensitive enough to yet, is understanding that recall for approximate nearest neighbor vector search really is an important thing. And people are not paying attention to it. People are not monitoring it either. They don't know, right? Because this can also change over time as you update the graph. And so I plug that, at least, as something that's also important.
Oh yeah, that's definitely quite important, and I hope teams start checking on the recall. So one thing, Sara, I wanted to go back to something you had mentioned a few times, which is about personalizing the models, adapting the models for your use cases in enterprise. I want to go quote Jerry from his past podcast, where Jerry mentioned, "Hey, RAG is an efficient hack," right? So I'm curious, under what circumstances you feel like RAG is sufficient, and when the team should put in the effort to fine tune. So essentially, what is your recommendation? When should the teams fine tune? When should maybe even build from scratch, or maybe RAG is sufficient for their scenarios?
Yeah, I think it's worthwhile thinking about. Yeah, this is a fun question. Wow, Jerry, I'm excited for you to come on after this. This sounds like a good from statement. Yeah, I mean,
Okay, wait. Hold on. Just to clarify to the audience, like I did a podcast with Swix on latent space, okay, and then I said the words "rag" is a hack, and then I said the words "but it's a very good hack," and he cropped out the second part and only put the first part and tagged on the Twitter release. So just for some context. Anyways,
okay,
back to you, Sarah. Yeah.
perfect. Yeah. Well, I think it's a fun starting point. So, I mean, the question of adaptation really gets this idea of why is fine tuning challenging. So, typically, the larger the model, firstly, the more cumbersome to fine tune because you have to update more weights, but also typically the more data you need to meaningfully update. Our hack to this with fine tuning is adapter style systems. So, often we have small little weight pockets that can be kind of switched in and out depending on the use case. Why it's beneficial is it means that although you're adding a few weights, it means that from a device perspective, you can fit into less devices because you don't have to host as many copies of the weights for different use cases. So, is RAG an alternative to fine tuning? It can be, but it can also be complementary. I think people don't realize this, is that you might actually have various different ways that you're adapting at the same time. It's actually not a clear, like mutually exclusive option. What RAG allows is probably, in some ways, a more traditional way of updating a model that might be familiar to enterprises, because your notion of how you're interacting might just be in terms of a database. And that can be quite beneficial if it doesn't feel as foreign as like maybe fine tuning or adapting weights. But I actually think the most interesting combinations will come from both. So maybe you'll do some ongoing fine tuning and maybe have adapters, which are specialized to different parts of your business, because you might be using the same model in various different areas. And then you might combine that with RAG. So I do want to kind of zoom out and kind of maybe speak to why Jerry might say it's a kind of an unsexy hack, if I could reframe it. Ideally, we have in the future, we have systems which are more flexible. Like these models, in some ways, it's pretty basic that we have to update all weights at once, that we don't have specialization within these massive models. And this is a key limitation. And there's very interesting research directions around mixture of experts where you have more specialization. But frankly, mixture of experts right now delivers on efficiency, but it doesn't really create true specialization. You kind of have to squint to see it. So I think there's just really interesting directions around that, where we avoid things like this, like imposing another database or a site set of weights after training. Because in some ways, what it means is we're doing acrobatics around the fact that we haven't designed a modular, flexible architecture from the get-go. So that's maybe my interpretation of why I could see why it might be cool to hack. But Jerry, I'm curious to hear what you think.
No, I mean, I think all your points I totally agree with. I'm trying to see if there's anything intelligent I can add. I think maybe the general abstraction I'm thinking is like the way I think about it is, if you think about LLMs as reasoning engines, every like vector database, like database API system, can be kind of thought of as just like a tool, right? And if you think about a human uses tools. Many of these tools are imperfect. Like if you search something like Google, you're not going to get back necessarily always the right results, but that means that you as a human will go back and enter like another search query or use Bing or something to actually find the results, or ChatGPT, right? To try to find the results that you're looking for. And so I think like what we're doing now with RAG is that we're kind of like bundling everything into one architecture. But really what RAG is it's an LLM of reasons over using a vector database as a tool. And so I think like what's interesting to me is that, if you think about an intelligent system, there will always be tools that aren't part of your own like system that you'll have to use and you'll get back information. But there will always also be potential like, potentially like a stuff that is like within kind of you, right? Like for instance, your own conversational memory or stuff. And so I just don't think we've figured out like the right ways to tackle some of these things like personalization and conversational memory, and how to actually integrate that maybe as part of the architecture itself. And I think of like kind of interacting with like a vector database, for instance, as just one example of tool use. But I think in the future, this will probably just evolve into some generic like agentic interaction with an external system, as well as being able to internalize concepts. And so I think that's like the part that I'm not completely sure where the like final architecture for that will be.
Makes sense.
I think in today's like current regime, we don't yet know, and maybe we'll never know. Maybe it's not possible to like deterministically update the weights of a neural network to get precise behavior to change, or precise facts to be changed, or whatever. And this is why Jerry's alluding to this idea of like separating out the reasoning capabilities of the language model from the memory capabilities of systems. I think that's like a pretty compelling idea. I think like in today's reality, one mental model that I think is useful, maybe it's not entirely correct, Sara can debunk this if it's wrong, is that fine tuning is kind of teaching a model like how to think, and then the retrieval or other like data sources is teaching the model like what to think. And obviously those two things combined can be pretty powerful. I think the reason that most people today are not doing fine tuning and mostly just retrieval is because it turns out like general English language how to think knowledge, which is what has been put into the model based on the entire internet, works pretty well for most domains. That being said, if you want to do like legal stuff or doctor stuff, that's a different way of thinking. It's a different ease. And so like that's probably a good case for fine tuning. I think in the future, we'll see. So today is relatively little fine tuning. I think we'll see a lot more fine tuning in the future, particularly as models get much smaller and faster. And people want to run them like in open source and otherwise. Like you'll see, I would wager to guess at least 50% or more of inference would be done by fine-tuned models versus like sort of generic models. Now, when does that happen? Maybe, I don't know, 2 or 3 years away. So that's certainly not tomorrow, but I expect to see fine-tuning become much more important in the future than it is today.
Yeah, that makes sense. Fine-tuning smaller models and making it efficient. And I think one of the other things is fine-tuning and RAG. They can all work together and really deliver the business impact. We have a few minutes left, but the results for one of the polls came back where we asked, hey, what metrics do you care about? And cost actually is one of the top metrics they care about. And then hallucinations, right? Like almost 70% of the audience cares about hallucinations, 60% care about cost. And there is one audience question that I want to ask in this regard. And Sara actually mentioned this, which was about efficiency, but primarily around quantization. And the question that the audience member is asking, how does quantization impact the quality of results? And how relevant are the techniques related to tuning deep learning related to tuning LLMs?
Yeah, I can speak to that. We've done a lot of research on quantization scale. So typically, up until very recently, there would be this really interesting phenomena where if you go above 6 billion parameter models, if you try and quantize, you see marked cliffs in performance. We actually released work this year that shows that a lot of this is because of the pre-training conditioning. So particularly if you use more robust representation during pre-training, like bfloat instead of float, even if you're using the exact same representation. So if you're using bfloat 16 versus float 16, you actually see that you have much better robustness when you quantize. So a lot of the quantization research now is like, how far can you push it? Can you go down to 1 bit? Can you go down to 4 bit without reducing precision? Why does this matter? Because quantization is one of those tools where you really are having your memory each time. So if you go from 8 bits to 4 bits, you're having it. 16 to 8, you're having it. So it's a very powerful tool to quickly reduce the number of devices you have to host on. And typically when you're in a multi-device regime, this is the biggest factor which is impacting your cost and your latency, because what it means when you're in a multi-device regime is that you essentially have to route and you have communication overhead, but it also means you're paying for multiple devices. And so this is really the crux of like the efficiency problem at scale, is how do we reduce it to fewer devices? And the dream, which Jeff is alluding to, is to get it down to the size where you have much more flexibility to fine tune. I actually think fine tuning is really critical just for adapting to data change over time. Even forget the personalization use case, but even core developers of the large language models, what we want to do is always be up to date with the data that changes. Language evolves over time. That's what makes it so powerful for how we communicate and how we connect to each other. So fine tuning is really critical. Right now, it's pretty cumbersome. So like, how do we make that easier? One way is techniques like quantization that just make these models more nimble.
Yeah, that makes a lot of sense. Jerry or Jeff, any thoughts based on your work?
No, I don't. Sara knows way more about this than I do.
So one thing before we run out of time, Jeff, I wanted to ask you, given that vector DBs have become such a crucial part in this generative AI journey for all the enterprises, what are the top 3 things that customers request that are currently not in the market?
It's a good question. I think that we're still, so, a lot of my comments about being fairly early in the adoption cycle here is because when we talk to enterprises, sort of ask them about, okay, like, what are your requirements? QPS this, latency that. We ask them about, like, what are the features do they want? We're expecting to hear back, like, oh, we really want to have like density and clustering. We really want to have these visualization tools. Everybody want this. And basically everybody is silent about all requirements. So like people don't know. They don't know what their QPS needs to be. And they also don't know like what other features would be beneficial. I think they're basically at the typical place that ML has been, deep learning has been for a long time, which is like, we made a thing with some demo data or some data. We got into this demo state, and now we want to put it into production. Like, what are the tools that are going to get us to cross the chasm? And of course, this has been a thing for deep learning for a long time, is that gap between demo and production. And that obviously still exists today, using language models, using embeddings. And so I think that's like the biggest one. If it's a singular point of like frustration, is like, hey, because the software, you can make things better, right? You kind of generally know, okay, it's not doing what I want. I should do this, this, and this, and then it'll be better. It's going to require time and work, but it'll work. I think with AI, it's a little bit different, where it's like, okay, well, it's kind of working. How do I make it better? And you're stuck. You're at a dead end. And so I think, if I had to choose like one thing that's like the biggest sort of like existential like fear or frustration with folks, that is what it is. Beyond that, I think that, again, we're not seeing people. People are still, at best, people are asking for a faster horse, right? They're not asking for the car. And I think in most cases, people aren't even asking for a faster horse. They're just saying like, why horse not good? So we're early. We're early. Yeah.
That's quite an interesting analogy. Thank you, folks. This is we are out of time. Thanks, Sara, Jeff, and Jerry. So much knowledge, so much information. Thank you so much. Really appreciate it.
Thank you,
Thanks, Sara, Jerry, and Jeff. That was a great discussion. Awesome conversation on RAG and fine-tuning and embeddings and all the goodness that is going to be coming out in the hours, days, and weeks to come.